The Wolff Kishner reduction is a way to remove ketones in the presence of base. There are several ways of doing this in an acid. Most of those, however, are going to involve heating it in the presence of a strong acid. And in a situation where this is not compatible with what we're trying to do, or there is something else that's acid sensitive on there that we don't want to ruin, we can use this method instead. And it begins by taking a ketone, converting this into a hydrazone like so. The next step, which is done in the strong base, the hydrazone is reacted with a strong base. This example, it's hydroxide. Hydroxide will remove a proton from this hydrazone, giving this resonance structure where there is a negative charge between the nitrogen and the carbon, the double bond going between the two. This will then react with water to the carbon. If it reacts with the nitrogen over here, it just goes back. When it reacts with the carbon, it goes to this next step, where the double bond is now between the two nitrogens, and the hydrogen that was on this hydrazone here is now on the carbon. The next proton is now removed by the base, and now there's a negative charge on the nitrogen, but this time the double bond is between the two nitrogens as opposed to having some resonance structure here, where it is more evenly distributed between the carbon and the nitrogen. The double bonds are just between the nitrogens now, which makes it easier for this negative charge, these electron pair, to now go between the two nitrogens and form a new bond. When this happens, this is able to leaving a carb anion and atmospheric nitrogen, which is a gas. This carb anion then reacts with water and creates this, which is what this is, but with two hydrogens. It has now been successfully deoxygenated.